This is the week 13 problem set explanation video. Moving on to question 1. It's asking us to have a function f for which f of 2 equals 5, and then when n is odd and n is greater than or equal to 1, the nth derivative of x equals 2 is given to us by this f of n function or series that we're given here, and then when n is even, it is 0. So it's telling us to write a Taylor series about f about x equals 2. So I started by doing your normal Taylor series definition. I found the derivatives of said function. I then plugged it into our Taylor series, and through this I was able to deduce that I think the Taylor series is 5 plus the summation to infinity at n equals 0 of n plus 1 factorial times x minus 2 to the n power divided by 2 to the n times n factorial. Now, this second problem is telling us to let the function of the given f of x equals e to the x squared, and we have to find the Maclaurin series for x. This first part was pretty self-explanatory. We just simply find out our first integrals, and then we apply our said integrals into our Maclaurin series, which was 1 plus x squared plus x to the 4th over 2 factorial plus x to the 6th over 3 factorial, continuing. And through this I was able to deduce that e to the x squared, its Maclaurin series was the summation from infinity to k equals 0 of x squared to the k power divided by k factorial. Now, this second problem to me was, I don't know, I think this problem was not very good, to be honest. It's telling us to find the Maclaurin series for this integral at x to 0 of e to the t squared of dt about x equals 2. And the Maclaurin is supposed to be centered around 0, so I don't know how it can be centered around x equals 2. But what I did was I found the integral of those first four numbers in the series, and through there I found that if you take the integral of this thing, you get what is called an imaginary error function, ERFI. So I'm not quite sure what to do about that. I don't think we have talked about that in this class so far, and the series that it was giving me was 1/2 square root of pi ERFI to the x, whatever that means. That's what happened when I took the integral of that function. So I'm not quite sure how I put that into a series. So moving on to problem 3. This problem was also, I want to say, not great. It's telling us that we have to find a function, well, we're given a function of 3e to the negative x over 6th power for all x's, and then we have a function h that satisfies h of k equals kf prime times a to the x for all x's, where we're given h of the x, which is just e to the x for a Maclaurin series, and that is just the Maclaurin series for e to the x. But somehow we're supposed to find f of x. We're supposed to find the constants k and a in this problem. To me, that just doesn't make any sense to me. I scoured the Pearson Plus notes, and I found nothing about how to do this. The only thing that was maybe close to this was evaluating some sort of y component at 0 and at 6, and finding a series that way. But finding two constant values for a series, this problem just it just didn't work for me. So I did what I did. I just did some simple algebra to solve this for one component, which is making k be a expression to the -6th and a being 1/3, so that when h prime of x will equal f double prime of x, which will equal e to the x. Yeah, this problem set was problematic, I want to say. I don't know if we might need to work on that, but yeah, that's about it.